Bink, 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 bink. So what is an offset? Okay, let's open up just a normal, ordinary TXT file like this. This is just a Walgreens note telling me to get iodine there. I never actually did it because Walgreens doesn't have it, and I haven't looked for it anywhere else. But anyway, that's irrelevant. So this is how it looks like in a normal notepad thing. Now let's open it up in our hex editor, in this case HXD, which you should be using because you're a good boy or a girl. Notice how it looks a little different. As you can see over here, it's represented in raw text data, which is what we can read. But what's this stuff over here? Well, these are bytes, and they're represented with a hexadecimal number. Bytes are what make up a file. So if you look into properties of your file, we have 196 bytes. And this is exactly 906 bytes. Well, 196, sorry. And basically this is basically all the information that is put in our file. So we have all the raw text here, and we also have the little line breaks, ODOA, that represents a line break. See? Watch as I change that. If I delete those, save. Now we look at the file now. See? Now it no longer has those line breaks. So we're going to put those back in. Whoops. Set into overwrite mode. I don't want that. ODOA, ODOA. There we go. And now it's back to normal. So just to drive the point home, yeah. These bytes represent everything about the file. Now, in a ROM, it's a little different because things aren't represented in raw text data. Because these bytes, these hexadecimal bytes, represent things other than just raw text data. It represents code, it represents images that the game reads, it represents sounds, it represents our event data and maps, all that fun stuff. So, let's look at these numbers here. We got 6F. What the heck is that? That's hexadecimal. I've said that a few times. So, a hexadecimal is basically just a different way of counting, alright? So, when we count in normal human language, we count to 16 like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, 11, 12, 13, 14, 15, 16. So that's how you count to 16 in normal human speak. In hexadecimal, it's a little like this. 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. 10. Alright? So basically, it's a couple of extra numbers before it gets to 10, and 10 itself represents 16 in hexadecimal. It's basically just a different way to count. So if you want to count to 32, you do this. 15, 16, 17, 18, 19, 1A, 1B, 1C, 1C. If you look to the left, you can see what number I'm up to. F20. Again, just a different way of counting. And as you can see, there's exactly 16 bytes per row for the sake of organization, so that when you go down one, you're at the next offset, which is 10. Which, let's get into the offset thing, because that's what this is about. So I have my cursor right here. It says my offset is 0. Let's move to the right 1 byte. Now we're at offset 1. Let's move down 1. Now it's at 11. Basically, an offset is a hexadecimal representation of a location in the file. So if we go over here, now it's 6A. If we go all the way to the end, that's C4. What is C4? 196. Same as our file size. So hopefully that gives you an idea of what the heck an offset is. But there's a little more to it than that. Remember in our events, gotta get our events, Lynn and Friends Go to White Castle. Remember when we wrote this? Basically, we told the event assembler, hey, I want you to put the events at this location in the ROM. And then we assembled the events, and then it gave us this stuff. I'll have to fix this later, but anyway. As you can see right here, it says our events end at this, D102BD. So let's go to D10000. That's the start of our events. That's where we started writing them. And then 2BD, 2BD. So that's where our events end. So it's basically a file put into a much bigger file. It's fileception. So naturally, when we write more events, this is what we wrote for the prologue. When we write for chapter 1, we don't want it to be in the same exact location, because that's basically telling it start here and write the chapter 1 events, and that's going to overwrite what we wrote for the prologue. So what we want to do is we want to put it a little bit ahead, like maybe here. You don't want to put it too close to where the original events were, because what if you want to edit the original events? What if they become bigger? What if you add more to it? Because if you make them bigger, it's going to seep out some more, and if your events are if your chapter 1 events are right here, it's going to seep out and overwrite part of your chapter 1 events. So you want it to be a little bit further out. And just to reiterate a point, D00000, that is the start of a bunch of space that is not used in the original game. It's just a bunch of thin air that the game just never used for some reason. So you can write whatever the heck you want in here. And it goes from D00000 to DFFFFF. Once you get to E0, blah, 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 this stuff is actually used. So anything in between D00000 to DFFFFF, that is completely unused space, and you can use it for whatever the heck you want. Just make sure you don't overwrite your whatever other stuff you put here. Alright? So, we're going to tackle one more thing. Notice the offset that we wrote here. Now, we wrote it there, but this thing has a little algorithm, basically tells the event assembler to go to a specific location where the event pointer table is. Now, the event pointer table is at a specific location. Now, when the event assembler writes this offset into the ROM, it doesn't write it exactly like this. What it does is it takes our offset. It's basically 4 different bytes to represent an entire offset, and it puts those bytes in reverse order, like that. And then it takes the last byte and adds 8. So if this was 1, for example, that would be 9. Alternatively, you could just think of it like this. It starts like that, then you put the 8 there, and then you just reverse them. Alright? Now, in Nightmare, it handles it a little differently. This is what a pointer looks like. And a pointer tells the game where certain stuff is. So let's find the offset of our pointer that tells us to go to this specific location. So basically a pointer would probably tell the game this number, except like that. So we could just literally just find it, and there you go. You hit Control G to hit, or Control F to find, then you set the hex values, and you can also hit Control G to go to a specific offset. So if you look at your thing, your event pointer table, it says to go to the 6th item in the pointer table. So this is actually the 6th item that the game looks at. This is the 5th, 4th, 3rd, 2nd, 1st, and 0th, because there is a 0 location. But anyway, so this is basically the beginning of the event pointer, the event table reference. the game looks at this for various things, such as maps, tile changes, your events, and basically, in your Nightmare editor, if you go into the chapter data editor, this chapter data editor thing, it tells the game exactly what certain things are. And if you scroll down a bit to event data reference, see that? So it's basically telling the game to start from here. The game already knows where the event table reference is. So it knows to start here, at this location right here. This is telling it go to the 6th item for the event. So it goes from here, 1, 2, 3, 4, 5, 6. And look at that. That's the pointer that tells it to go to a specific location. And remember, that's in little endian, so if you reverse it, if you want to change it from this to to the normal, what it actually is, it would be that. Sorry. You basically just reverse the bytes and remove the 8 to bring it back to what it originally was. And then you just type in the location. And look, it goes to where we put our events, which is right here. So hopefully that explains everything. That last bit about the little endian, you probably won't be using it too much. Just take note that when you write it in the event assembler or in the tiled map inserter, that's what you type it in as. But when the game writes it into the ROM, it writes it in as... It changes it from this to this. It reverses the bytes and adds the 8. And when you are in the Nightmare editor, it displays as this. It's basically your offset, but it adds the 8. So it doesn't reverse the bytes. It's a little complicated, but hopefully you'll get the hang of it. I think that's all there is to say about offsets and whatnot. Basically, think of when you write your events into a specific location, it's like you're putting a file into a bigger file. Alright? I think that's all there is to say. I hope I got everything. So, if you have any further questions, let me know.